Hello everybody, I am Layan and today I will talk about how does Earth magnetic field vary with location and time. So as the beginning, I want to remind you what is the magnetic field. So a magnetic field, it is the force around a magnet, as you can see in this picture, the lines representing the magnetic field. What is Earth's magnetic field? Actually, Earth have magnetic field. Why does it have it? It have it because of the inner cores having some metallic fluids. For example, in the inner core and the outer core, they consist of molten iron and solidified elements. Coming to the Earth's magnetic field component, first the magnetic declination, which is an angle between the true north or the geographic north and between the magnetic north. In the Earth, the magnetic poles are switched. So the south pole, it's on the north of the Earth, and the north pole, it's on the south of the Earth. Coming to the magnetic inclination, it is known as the angle of dip. It is the angle made with the horizontal by the Earth's magnetic field lines. This angle varies at different points on Earth's surface, so it's different from point to point. Positive values of inclination indicate that the magnetic field of the Earth is pointing downward into the Earth at the point of measurement at the northern hemisphere, and the negative values indicate that it is pointing upward at the southern hemisphere. The range of dip is from negative 90 degree at the north magnetic pole to positive 90 degree at the south magnetic pole and 0 degree at the magnetic equator. Third component is the intensity of Earth's magnetic field. It is explained by two components, the horizontal component and the vertical component. The magnetic declination. So magnetic declination, it's the angle between the true north, as we said, and the magnetic north. And this component varies based on location and time. It's different. It's different from location to location and from time to time. Now let's see this example. The following website can be used to find this angle using a map. It is useful to correct the compass reading, for example, when trying to construct a mosque that should be toward Qibla direction. Now I'll explain this example. Stay with me. So here's the website and I open it and this is what showed. So for example, first I'll give you an example. Here we are in Dubai in the United Arab Emirates. The angle of declination, magnetic declination, as you can see, it's positive 2. And the magnetic field strength, as you can see, it's 44,000 NT, which is very small amount, okay? But it's 44,000. Okay, for example, here we are in Dubai. If we go up, for example, let's take Russia. Where is Russia? Here. So here is Russia. See, the magnetic field strength is 53,000. 53,000. That means whenever we go up, more up to the poles, for example, up on Earth, it's the south pole of the magnetic field, okay? So it will be more stronger. And if we went down also more, let's go to Antarctica here. See, it's even more, 44,000, 49. See, whenever I go more down, see here 52,000, it will be more stronger. The magnetic field will be more stronger near its poles. Now, I will give you an example, which is when we want to build a mosque, okay? When we want to build a mosque, we use a compass to know the Qibla, okay? But the compass actually, it gives us the direction according to the magnetic field, and we don't want that when we are building the mosque. So we need the direction of the correct geographical area. So what do we do is, for example, here the magnetic declination is positive 2, so we minus from the compass, we minus 2 degrees, as given, and then the correct Qibla will be given. And then we build the mosque according to that. Now coming to the field variation. So on Earth, magnetic field is different at different locations, as I showed you before on the map as we saw together. The magnetic field changes with both location and time. The distribution of magnetic field is measured using satellites and approximately 200 operating magnetic observatories worldwide, as well as several more temporary sites. The sites, such as the site we worked on it together in the previous example. Now, the field variation, okay, as we said, it differs. The magnetic field differs with time and also location. The Earth's magnetic field is slowly changing and appears to have been changing throughout its existence. So scientists believe before a very long time, before maybe thousands and more than thousands years ago, the poles were on the correct, like they were on the south there was the south pole, and on the north there was the north pole. But nowadays, as we can see, or as we can know, that the magnetic field according to the Earth, the south is on the north, the south pole, and the north is on the south, so it's on the opposite. And a geometrical reversal is a change in a planet's magnetic field, such that the position of magnetic north and magnetic south are interchanged, not to be confused with the geographic north and geographic south, as I said. And this was the end of my presentation. Thank you so much and hope you enjoyed.